Let me just say welcome. My name is Bennett Brooks. I'm a senior mediator with the Consensus Building Institute. It's been my pleasure to do a bunch of different work in Piermont over the last several years, including working with Peter Sheng and the other members of this team for the last couple of years. I just want to acknowledge at the outset that this is the end of a long day, I'm sure, for many of us, and a long day on a lot of Zooms, probably too many Zooms. And I just want to really thank everyone for making the time to do one more Zoom, probably before your day ends. And we appreciate it. And we hope we will be putting together a presentation that is interesting and informative. And as you know, we're really looking forward to sharing the results of a 3-year study that Dr. Sheng has been leading. And the focus of that study has been on understanding the role that Piermont Marsh plays in buffering Piermont from storm-driven waves and floods. We had really hoped to do this in person. It would be way more interesting, and we'd have a lot more conversation back and forth. But this is the world we're in right now, and so we appreciate your sort of flexibility to be online with us. So thanks for that. We have a lot to cover tonight. The study covered a lot of territory, and we really want to share that with you and share as much of our learnings as possible. Maggie, if you go to the next slide, please. Thanks. So our purpose tonight is a couple of things. One, most importantly, we want to share with you sort of the findings from Peter's study. And that really falls into sort of three bins. One is, what was the role Piermont Marsh played in buffering Superstorm Sandy? We know it was a lot of damage in the village, but how much worse might it have been if you didn't have the marsh share playing some buffering role? The study also looks at the buffering role of the marsh into the future. And so imagining different kinds of storms, and then as well with projected sea level rise and understanding what role might the marsh play into the future. And again, trying to quantify all of that and say, in dollars and cents and economic damage avoided, what's the role the marsh plays there? We also know that you all are a group that cares a lot about the marsh and its relationship to the village. And so the state DEC really wanted to take advantage of having this group here and give attendees an update on marsh conditions and restoration plans. That will not be the focus of the conversation tonight, but we know it's a topic of great import, and so we wanted to be able to, take advantage of the fact that we have this group here. So we'll do that as well. Next slide, please, Maggie. So topics after just some of this intro stuff. We'll actually do the Piermont Marsh introduction and management update first. And we'll hear from Sarah Fernald and Heather Gearloff with the New York State Department of Environmental Conservation Hudson River National Estuarine Research Reserve. Again, we'll get a little bit of an update there, have an opportunity for some Q&A. And then at around 7:35, we'll hand it off to Dr. Sheng, who will share with us the results. Peter will probably talk for, 25, 30 minutes, and then again, more opportunities for Q&A. And then towards the close, we'll hand it off to Nathan Mitchell, one of Piermont Village trustees, to talk about the village's plans for going forward. And we will adjourn by 8:30, and we will, as I mentioned, provide opportunities for questions after each of the presentations on Piermont Marsh management update and on the study results. Next slide, please. So just a few protocols here. Again, webinar format, it's a little less complex. We're mostly sharing information with an opportunity for Q&A, but things we sort of expect from each other and encourage is, first of all, be comfortable. This will be an hour and a half, and so if you need water, you need a beverage, you need snacks, get it, a comfortable chair. Stay focused. There is a lot of pretty detailed information that we'll be sharing this evening. And so the more you can focus, I'm sure the more you will get out of the results that Dr. Sheng will be sharing. And then we want you to use Zoom to participate. And we'll use it in really one main way, which is if you have questions that you want to ask, and I'll tell more about this in a second, we'll ask you to use the Q&A box on the bottom of your screen, and I'll demonstrate that in a second. But we definitely want to hear from you. We want to get your questions, and we'll try to fit in as many as we can given the time that we have. A couple of folks have asked already, but Everyone, all of the webinar participants, you will be muted the whole time and not on camera, so you do not need to worry about talking and interrupting the presentation. You don't need to worry about if your kid comes in and needs a hug. You're good. We're not seeing or hearing anything, so relax into that. Next slide. So just when you look at your screen, I mentioned a moment ago, you can ask a question of a presenter, and what you'll see is if you look, you see I'm circling around the Q&A. If you want to pose a question, if you just click on that Q&A, a box will pop up and you can type a question in there, and then we will see it. As well, if you can, even if you're not posing a question, you can open that box as well and see the kinds of questions that are being posed. And if there's a question that you think is particularly important, you can upvote it. And when you open that box, what you'll see, and you look at someone's question, you'll see a little thumbs up. If you click on that thumbs up, that's a way of saying, yeah, that's an important question. I'd love to hear an answer to that one. So again, we'll get to as many questions as we can. A couple of people have already written me to ask whether or not the webinar is going to be recorded. It will. The webinar is being recorded. The webinar and the recording and the slides, as well as a project summary, will be made available. They won't be made available, however, until October 1st. And I know that feels like a long way from now, but Dr. Sheng and his team, we really need to be respectful of their need to complete the work and complete their writings before this is all disseminated widely. So yes, it will be recorded. Yes, we will make it available, but we won't be able to do that again until early this fall. There's a question from Klaus Jacob asking, how many folks are on the webinar? Right now, we have 63 people on the webinar, including those of us who are panelists. So we've got about 60 folks. And based on the pre-registration, I'm expecting and hoping that will continue. There's another question: are the town board and the mayor participating? You certainly have Nathan in the mix. I believe I saw the mayor's name. And Nathan, maybe you can scroll through the participants and see if you see others. Yep, I see Kelly Ruby's name is in as well. But Nathan, if there's others, I'll let you fold in with that.
Those are all I saw so far.
Okay. All right. So with that, let's go to the next slide. One last thing just to mention is I just want a note of thanks. I want to thank the end users who have advised us on this project, and you can see the names there. Most of those folks are folks who are in Piermont, involved in resilience work or on local boards. Ed McGowan may be a name you may or may not know. He is the marsh manager, so he was involved in that as well. And then many thanks to the planning and technical team, to Peter, obviously to Dr. Peter Sheng, who's led all of this, to Heather Gearloff, Emily Hauser, and Sarah Fernald with the state. And then there's many other members of this team who Peter will be introducing. So with that, I want to hand it off to Sarah Fernald and Heather Gearloff and let them walk us through their presentation, and we'll take some questions about the work they're doing after that.
Hey, thanks, Bennett, and welcome everyone. Thank you for joining us tonight. I'm Sarah Fernald. I'm the research coordinator for the Hudson River National Estuarine Research Reserve. We also call ourselves HRNER, and our mission is to protect tidal wetlands. We are a federal program funded by NOAA. We administer our program in partnership with the New York State Department of Environmental Conservation. HRNER was designated in 1982. And it consists of 5,000 protected acres of tidal wetlands across 4 component sites. Next slide, please. We are part of a network of 29 research reserves, as you can see on our map. Almost every coastal state has a research reserve, and we have this shared mission, and that is to protect, oh, I just lost my screen. Hold on. To promote the stewardship of the nation's estuaries through science and education using a system of protected areas. Next slide, please. And you can see here, we've got those protected areas are distributed across our 4 component sites. And the southernmost site is Piermont Marsh, and that is why we are involved in protecting these tidal wetlands. North of Piermont in Bear Mountain State Park is Iona Island. Adjacent to Bard College is Tivoli Bays, and then just north of the city of Hudson is Stockport Flats. Our headquarters are based at the Norrie Point Environmental Center in Staatsburg. Betsy Blair had been our Herner manager from the beginning, back to 1984 until 2018, at which point Heather Gerloff has taken over that role to the present. Next slide. So why is protecting tidal wetland function important? We know that healthy tidal marshes support a wide variety of native plants, animals, insects, and microorganisms, like this lush example of Piermont Marsh pictured here with a wide variety of plants. Next slide, please. The native vegetation supports marsh health, and it maximizes the benefits of these tidal wetlands that those benefits provide for fish, wildlife, and humans. Potential threats to the native vegetation need to be monitored. One of those threats could be pictured here, the open water pans, or the pool areas toward the center of the marsh. And that area is in that inset map there, outlined in red. These pools, they're a really wonderful area of diversity along the edge of the pools, and they contain a lot of fish and support a lot of wildlife. However, they could be a sign of marsh degradation in that the water gets trapped in there and causes the marsh to sink and maybe, if you will, falling apart by the inside out. But we're monitoring this to see if that is the case. Next slide. Another potential threat to tidal wetlands is rising waters, both in the form of storm surges or sea level rise. Now, because the tidal wetland vegetation, by definition, needs to be in that intertidal zone, if the water levels are increasing, the tidal wetland would either need to grow vertically or build up more sediment so that the vegetation would stay in that intertidal zone, or the whole marsh would need to have horizontal growth or shift inland. And we know from Piermont, the shores are extremely steep and there's very little opportunity to shift inland. So therefore, if there's insufficient vertical growth with sea level rise, it could lead to widespread marsh loss. Next slide. So a diverse assemblage of species helps to protect the marsh, as each species fills a different niche and provides a wide range of environmental services. So pictured here is a muskrat lodge, giving an example of a habitat service that the marsh provides. The marsh also fills some ecological chemical cycling roles, such as carbon sequestration and nutrient processing. It also has several habitat functions for nesting birds. It serves as a rest stop for migratory birds, a nursery habitat for estuarine fishes, foraging habitat for bees. And then it has several human-focused services, such as recreational opportunities. And like Peter Sheng's study that we're about to hear about explored, is the storm protection service for human communities adjacent to the marshes. So without further ado, let's move on to the next slide. And I'd like to introduce our current Herner manager, Heather Gerloff, and she'll be further explaining the plans for how to protect this vital tidal marsh habitat. So on to you, Heather.
All right, I hope you can hear me.
You can.
Thank you so much, Sarah. As you mentioned, I've been the manager for just the last couple of years. And I was just hoping to spend a little bit of time with the attendees to kind of go over our current monitoring and management of Piermont Marsh. It is so important to the area. I also wanted to go over a little bit of history on how we got to the management plan and how we involved Dr. Sheng in his work. So Piermont Marsh is so vital for the local municipality. And it also became a target for looking at offsetting the impacts for replacing the Tappan Zee Bridge. It became really apparent early in the process that the way the permit was written was really vague, and if implemented, may actually have an impact on the ability of the Piermont Marsh to buffer the village from any storm events. And so the team got together and we decided that we would have to retool this idea and come up with an alternate control, a plan to control the Phragmites. And we focused in on an area interior to the marsh where there is some persistent native vegetation. And you can go to the next slide. When crafting, so what we did is we came up with an alternative Phragmites control plan that was much smaller than the footprint proposed in the permit. We included this as well as many other actions into a draft Piermont management plan that was released to the public in 2017. It included 4 main goals, and you can see them listed on your screen. Was to maintain the marsh's ability to provide storm protection, to sustain native marsh communities, to promote resiliency of the marsh, and so that it could protect the village from storm events, sea level rise, and other disturbances, and also increase our scientific knowledge of the marsh. Parallel to this management plan crafting, we were also partnered with the Village of Piermont and to create a research question. And with the partnership with the Village of Piermont, we developed a research question and we're seeking out researchers. And when searching out researchers, we found that Dr. Sheng was an excellent fit. He had experience in 3D modeling. He also had experience in assessing the buffering capacity vegetation in light of storm events such as Katrina, Rita, and Wilma. So the reserve worked with the Piermont end user groups and Dr. Sheng to get funding from the NERRS Science Collaborative research group. And that's why we're here today, because we were able to work with them and fund Dr. Sheng's research on modeling and understanding the marsh's role in buffering the village from storm events. So we'll hear about Dr. Sheng's results after this presentation. So in the next few minutes, what I'd like to do is just go over the draft management plan status, where we're going in the future, and what monitoring has been going on in the last couple of years. Okay, so you can go to the next slide. So New York State opted to hold off on implementing the draft management plan that was presented in 2017. We plan on redrafting that plan and presenting it to the public in 2021. With that new plan, what we anticipate is that any large areas of frag control will be removed. We want to be responsive to the public comments that we received in 2017. We're going to include all the progress and results we got from monitoring the marsh in 2019 and 2020, and I'll be going over that in the next few slides. And we also want to inform this new draft with Dr. Sheng's final results that we expect to hear about today and finalize at the end of September, beginning of October. So next slide. But I need to go over a little bit about the 2017 plan because you are going to see this plan as the basis for Dr. Sheng's research. Originally, we were planning to control 40 acres of Phragmites over 10 years in 3 phases. In 2020, we still want to adhere to our goals laid out in our 2017 management plan, one of them being protecting of the native communities. So there's still value in everything that was laid out. We just may not implement them the way that we laid out in 2017. So in 2020, we've held off from using any kind of chemicals, but we still wanted to do our best to try and protect native vegetation. So I want to take your attention to phase 1, which is the area that's lined out in yellow. In that yellow area, there is a light purple blob per se, but that is actually native vegetation. And one of our concerns with native vegetation is if we sit back and let the Phragmites dominate the area, we may lose the ability to protect the native vegetation. So what we decided to do is come up with a small area, it's about less than a 1/4 acre, and cover it with geotextile. That was a method that's been used in Constitution Marsh. It also was suggested by some of the commenters on our 2017 draft management plan. I'm going to go into that detail on the next slide, so you can go to the next slide. Okay, so here that purple blob is now a green blob. And what that is that's the native vegetation we really do want to try and protect as much as possible. We all know that biodiversity and a variety of plant species is really good for the health of the marsh. So what we did is we decided not only to look to see if we can control the Phragmites in a small area, but to also increase our scientific knowledge of implementing something like that. So what you're seeing on the bottom is the implementation, it's the installation of the geotextile that happens in June. And on the right is the plots that were laid out. So what you're seeing are 3 locations. The purple center is where the geotextile was installed. That area is predominantly Phragmites. The plot to the left, which is a red box, those are vegetation plots that are in areas that are all Phragmites. And then there's a yellow box with plots in it. Those are the native vegetation. What we plan to do is monitor these vegetation plots over the next few years to see how they're changing. And also we're hoping to see that when we remove the geotextile in 2 years, that hopefully the native vegetation that's surrounding it will opt to come into that area. If you don't know about geotextile is a woven plastic fabric. It allows for water to penetrate through it, but it does block out the sun and holds in the sediment. So we're hoping that this smaller area will transition from a primarily Phragmites area to native. And if we're successful and we find that this is a good method, we may be able to replicate it again in other locations surrounding this native area. So in addition to protecting native vegetation, we're also interested in learning more about the current conditions of the marsh, so we can better be informed on how we might assist in protecting and enhancing the resilience of the marsh. So next slide. So how we're doing that is LiDAR is a survey method that we've just recently implemented on the marsh. That was a flyover done in April 2020. Prior to this, in 2012, the LiDAR was done. And the reason why we thought this might be helpful was because we could come up with the existing topography, the existing elevation of the marsh. And as Sarah mentioned before, we have some concerns on how this marsh might be changing. Are we seeing more water? And actually, in this LiDAR map that you see on the right, you'll see the brown is in the hill that's near the dog park. I think everyone's probably familiar with the dog park if you're familiar with Piermont. And the aqua area is the water, and the deep blue areas is the deepest of waters, and that's the junction of where the marsh meets the Hudson. And so what you're seeing is there's some darker green, and I think it's hard because I can't point to it, but in the middle of the marsh, you'll see some dark, yes, right there, perfect. Those areas are showing you that there's some water there because it's deeper than the browns and the yellows. So there is some increasing water on this surface, or at least we don't really know what's happening here. And so what we are hoping to do is create a baseline map so we can track this in the future and hopefully have an analysis on if it's changing over time. Now, the dark blue that you see on the periphery, that's the junction of the Hudson and the marsh. And you can see along that edge, there's scalloping. You can see how the edge is not even, but there is scalloping. The scallop area is erosion. Our concern with the erosion is that over time, if the marsh becomes narrower, that it may not be able to protect the village from storm events, because honestly, the size of the marsh helps protect the village of Piermont. So next slide. So the question of erosion on the marsh edge is something that we still want to learn more about. And what we've decided to do is work with the Thruway Authority and AKRF to lay out transects along the marsh. And what you're seeing on this picture is on the right is a typical cross-section, a transect. You can see there's benchmarks included, there's vegetation and measurements. So the benchmarks are going to be the reference locations, and we're going to go out and measure the distance from those benchmarks to the edge of the marsh to learn more about the rate of erosion and maybe start getting informed on how that erosion or why the erosion is happening. What we have found by looking at ortho imagery is that we potentially have lost 50 feet of marsh edge since 1920, so in the last 100 years. And what you're seeing on the bottom is a picture of the erosion close up. What's happening is as the river comes in, it takes out sediment that causes a void under the vegetation and sloughing, and then eventually those pieces of sediment that are sitting there eventually make their way to the Hudson, and that causes the re-erosion on the marsh edge. So our monitoring is also including some analysis of the generation of wave and wave energy. You can go to the next slide. And so the question for us is there something that we can do to minimize the erosion rate on the marsh so that we can continue to protect the village and protect the marsh for the long term. And so again, we're working with the Thruway Authority to craft a pilot project to see if there's something that we can do on the ground to work and protect the marsh edge. And we've come up with some candidate areas. On the right, you can see a map, and in yellow, it says primary and secondary. The primary was picked because there's an oxbow right next to the shoreline. That oxbow is a bend in a creek. And if we lose a little bit of that edge there, we're worried that the oxbow would connect to the Hudson and in turn potentially lose a significant portion of our marsh. So that is exactly, very good, thank you. So that area is our our primary location to look at. If we're successful in having enough timing and potentially some preliminary grant funding, we would also look at the secondary candidate area. Okay, so you can go to the next slide. So when we talk about the pilot project, what is that? And what that is that we're working with AKRF to come with a plan to come up with ideal materials or potential materials in certain locations that a person could put on the land absent use of machinery. So we anticipate going out to find grants and match funds and using volunteer work hours through either SCA or other groups to implement some preliminary projects. And so the preliminary projects are not crafted, the plan isn't finalized yet, we're still in the process. And what you're seeing is a couple of products that might be used in that plan. So that plan is something that we hope to include in the draft management plan that will be released to the public in 2021. And on to the next. That's it. And so I just wanted to summarize to say that most of everything that I've talked about today, we anticipate being included in the next draft of the management plan, and that we would have that out for public notice, just like we did in 2017. It will be done most likely in 2021.
Great, thanks Heather so much. Again, we have a few minutes for some questions here. We won't spend too much time here because again, we want to make sure Dr. Sheng has ample time to present on his. But Heather, a couple of questions in the chat. The first one is, do you have reasonable assurance that the geotextile cover will stay in place during severe storms? Well, we've used a stapling technique. So we have the entire geotextile grid that's out there staked down with significant wooden stakes. We do anticipate going out after storm events to double check to make sure that it's still intact. Okay. I have another question specific to Piermont Marsh, and then there's a third, which I'll go to, which is a bit broader. The second question that is specific to Piermont Marsh is, early on, there was discussion of, on the east side of parallel on the east side of the marsh to place oyster beds that could reduce wave action and hopefully manage that erosion on the eastern marsh edge. Can you explain sort of the thinking around, is that scheme being pursued? If not, why not? Status? Okay, so oysters do well with consistently saline waters, and the river water that is best for that in the Hudson River are in depths of 14 feet of water. Anything in the upper parts of the column don't have enough salinity to
allow for oyster propagation. But what you had seen on the previous slide in the bottom are called oyster castles. So even though we may not use oyster, there we go, on the bottom picture are oyster castles. Now they're used in other areas such as South Carolina, the Chesapeake, to be substrate for establishment of oyster beds. We don't anticipate putting them in for the use of oysters establishment, but I think they can still really they could probably reduce the erosion rates, and that's what we're anticipating using. You can see these people are doing it by hand, and likely that's what we'll end up using.
Thanks. And then I've got another question before I do that, though. Just remind people, again, if you want to pose a question, if you take your cursor and put it on the bottom of the screen, you'll see Q&A, and if you click on that, you can type a question in there, and if you don't want to ask a question, but you see a question that you think is important, you can give it a thumbs up, and that'll tell us that it's a good one to make sure we have time for. The last question right now that I have is around one participant asked that they've heard that the DEC is exfoliating non-residential marshes up and down the Hudson, and would like to understand what is the environmental is that accurate, and what is the environmental justification?
I guess I'm not quite sure of the question. So can you restate it?
Yeah, I'll just read it verbatim. I have read that the DEC is exfoliating non-residential marshes up and down the Hudson. Can you explain the environmental justification?
Yeah, I don't know that that's happening. That doesn't sound like something I'm aware of. We have a couple, at Iona Marsh, there is some frag control, but exfoliating is not something that I think is going on at this point. So maybe if they have more specifics, they can contact me directly on that.
Okay, great. And again, obviously Heather's contact information is right there on the screen, yep. So we'll leave that up for another 30 seconds or so. Again, we have another minute or two if there's any other questions. You throw it in the chat super fast, we can get to it.
And I can just say, probably best to use the email at this point. Phone numbers are difficult as I don't have a specific day and schedule being in the office.
Good point. So please pose a question to the email. Okay, well, Heather and Sarah, thank you so much. At this point, what we want to do is shift to hand things over to Peter. And so Peter, while I'm introducing you, I'll let you share your screen. Dr. Sheng, as I mentioned, has led a team of folks who have been thinking about this question and really trying to understand what is the role Piermont Marsh plays in buffering storms. It's been a fascinating bit of work and some interesting findings. And Peter, I'm going to hand it off to you. And Peter, if you're talking, you may be on mute.
I've just unmuted you, Peter. You should be good.
Yeah. Good evening, everyone. It is a pleasure to be here talking to you today about what we found in the last 3+ years on this interesting and important project, assessing the value of coastal marshes for protecting coastal communities from storms in a changing climate, not just now, but also in the remaining of 21st century. This project has been really interesting, and it reminds me on January 11, 2015, 5.5 years ago, on a very cold night, I was invited by Betsy Blair to attend a town hall meeting where all the end users and marsh managers, and I don't know, Ben, you were probably not there, but there are a lot of people there. It was very cold outside, but very warm, and sometimes you even got hot inside the building because there was an interesting discussion about the future of Piermont Marsh and Village. So after the meeting, January 11th, people have been working on this for months, but after the meeting, it became clear that we need to start writing proposals. So, you know, one thing led to another with the help of everyone. In about 18 months, we got funded by NERRS Science Collaborative. So I'm here to report to you what we found as a result of this study. I'd like to thank everyone on this team. We have a very talented group of scientists except myself, from University of Florida, and we have ecologists, wave and water management experts, coastal modelers, economists, climate scientists from University of Florida, Miami, NASA Goddard Institute of Space Sciences, and we also have 3 students. 2 of them have graduated, 1 is still working. We also have USGS hydrologist, Ron, and we have a good representation from the end user group, Ed, Klaus, and Nathan. They're all here, I believe, and we have excellent collaborative lead by Bennett and Heather, and formerly Betsy, and of course an important contribution from Emily and Sarah. And I want to thank Bennett and Sarah for going over these research goals and outputs and outcomes already, so I don't have to repeat them again. We basically want to do a forensic study on the role of Piermont Marsh in protecting the village from storm damage during Sandy as well as future storms, and inform the marsh management and community resilience planning. Key outputs including a quantitative assessment of the marsh's buffering capacity during future climate conditions or originally proposed management scenarios, and economic evaluation of the service. So we know the center of the universe is Piermont Marsh and Village, at least for tonight. This marsh is composed 92% by Phragmites, and the rest of them are native species like typha and Spatina and others. This marsh and village was attacked by a superstorm Sandy, October 30th, 2012, and which created massive damage along the New Jersey, New York, Connecticut coast, as well as in Piermont, because of the very special characters of huge size. New Jersey landfall category 1 intensity coincided with a high tide. And so what we are trying to do in this study is to try to do a forensic study again, understanding the role of the marsh played in protecting the people of village, and if it's going to be able to do the same thing in future storms. So here is a very busy diagram, which basically shows all the ingredients of this study. The yellows are elements are the models. Of course, in the centerpiece of the high resolution, 4-meter resolution vegetation resolving storm surge wave model for Piermont. It can use the vegetation data provided to us and simulate flood and wave and damage with the economic model. But this model needs to be supported by a large-scale surge wave model, which covers the entire New Jersey, New York, Connecticut coast. And they both use the Sandy wind field. And the large-scale model gives us the storm tide and wave condition in Hudson River, but provide boundary condition for the high-resolution Piermont model. And once we have the economic analysis done for Sandy, we compare with the NFIP and PWRC data, National Flood Insurance Program. Everybody knows about PWRC. So we verify the economic analysis produced the right number of structural loss. Then we go back and look at the storm ensemble, 300 storms that might happen in the future. These are not 300 Sandys, but 300 less intense, more frequent storms. And we run 300 storms alongside with sea level rise scenarios and marsh management scenarios provided by the user group. And we run these models, again, using 2 models and 300 times, produce the flood and wave in Piermont, and doing economic analysis, produce the structural loss during these 1% event. So, and so we have an added bonus here because of the extra time we got from Lane Vaccaro. We produced a web tool, a web-based decision support system, which I'm going to talk about a little bit at the end, which can be used for resilience planning. So that's everything in a nutshell. So I want to describe to you with my animation cartoon and Matures animation about what happened during Sandy. So on a typical day, the Piermont Marsh is about 12 foot tall, as you see the green line here, and much higher than the water level, which is shown by the blue line in Hudson River. And there's a fish swimming by Hudson River, and you have wading birds here, and people enjoying a nice day in the village. But when Sandy comes on the day of October 30th, things changed. What did change? So here we're looking at the nice, good-looking Piermont Marsh Phragmites, tall and dense, lots of debris, sediments at the bottom. And now on the day of Sandy, the big fish disappeared. We have little fish and wading birds flew away. And now we have somebody on the lookout watching what's going on in the marsh. So the marsh is 12 foot. And because of strong wind from the west, the water level, the storm tide got up to 9.5 feet, got up to here. And the 9.5 feet, so this is all in NAVD 88. Because a relatively narrow marsh width, it didn't dissipate much of the storm tide. Storm tide at the village, at the south end of the village is about the same as what you have here at the in the river. But you have 2 to 2.5 feet peak wave was dissipated significantly within about 500 feet. So by the time we get to the village, is less than 1/3 of the wave height at the edge of the marsh. The dense and very tall Phragmites marsh blocked flow and debris. It couldn't reach the village. So the marsh did what it's supposed to do. It protected people from wave damage and current flow and transport of debris to the village, although it didn't attenuate much of the flood. And village, according to our estimate, suffered about $11.8 million structural damage, but avoided about $902,000 loss due to the presence of the marsh. So marsh was protective of the village on the night of Sandy. So the users want to know, what if these tall, rigid Phragmites were replaced by shorter, flexible typha, which is what you have in Iona Island. And we did some model simulation looking at the tall Phragmites on the left, relatively a little bit shorter, a little sparser typha on the right in Iona Island. Interesting to note that Phragmites height and density don't change much throughout the year, but the typha height and density shows more variation over the year and became much lower in May. So if a storm hit in May, typha may not be able to buffer much of the damage. So here are our model results, considering these two types of marsh for the entire Piermont Marsh. With the existing Phragmites marsh, didn't buffer much of the storm, surge and flood, less than 1%. The wave at the southern edge of the marsh is compared to the wave at the marsh edge is less than 1/3. Current is completely buffered, as well as the debris. If consider the typha measured in September, the same buffering capacity is maintained. Had a hurricane hit in May, when typha was lower, then it would have lost the capacity for buffering wave and debris. Of course, no marsh, you don't have any buffering capacity. So Piermont Marsh, again, covered wave debris, but not flood during Sandy. So we need to do economic analysis to understand what is the structural loss to the entire village. We're not trying to identify individual property loss. We're not an insurance company. But we're trying to answer these questions. These are the questions we're trying to understand. How do they compare with the FEMA NRIP payout? How much additional damage would incur if Piermont Marsh were removed? Would the original marsh restoration impact the structural loss of the village in the future? Now, here are three plots showing the maximum flood elevation, maximum wave height. We're indicating the wave height and flood elevation at a property at Klaus House here, and then at the edge of the pier. And here we use about 559 records of properties from the village that are residential properties in our damage assessment. And so we try to answer the above questions. Now here is a diagram from FEMA. The idea of here is to show that both the surge, the flood elevation, as well as the wave that sits on top of the surge can produce damage to the property. And we have used our surge wave model. We calculate the surge flood over the region, and we calculate the wave over the region. And then we need to do damage assessment. So the damage assessment in a nutshell is calculate the flood elevation, wave height, calculate flood elevation, and something called wave crest. And then we find out which flood zone this property is in, which house is in, and then calculate the damage of individual buildings due to flood and wave. And that's how we do the damage assessment. We basically combine the methods of FEMA and Army Corps of Engineers when we do that. So it is how we did. When we considered 41 properties which were paid by FEMA after Sandy, these are the structural loss. 2.61 million due to flood damage, 1.11 million due to wave damage, total 3.72 million with wetland being there. Now, if we don't have the wetland, without the wetland, the damage would have increased to 4.28 million. Avoided loss, $153,000, or a avoided loss in percent is 15.1%. And this number compares very well with the NFIP payout of 3.47 million. Now, if we consider all the properties, 559 properties, what do we get? We would get a loss of 11.9 million. And if we remove the wetland, damage would have increased by $902,000, a percent of 7.6%. And this
Peter,
number,
I'm going to, sorry, no, finish that and then I'm going to jump in with the question.
11.9 million compares very well with the estimate by PWRC of $20 million, which includes things like docks and marina, which we don't consider in our study.
Yeah, just let me jump in with a question from someone just to clarify. When you're talking about the marsh being there or not being there, you're not talking about phragmites being removed. You're looking at more of a hypothetical. If the marsh were not there, what would we expect to have happened? Correct. Okay, good.
Exactly.
Just want to answer that question in the chat.
We completely removed the marsh. Now, we cannot manage the marsh. You cannot do resilience planning based on a single storm, Sandy. Sandy may never come back again. The next time a storm hit is going to be very different. In the next 50 years, 100 years, you expect very different storms. So the typical way to do this is we have to look at ensemble storms that may occur in this region. And to produce those possible storms, we seek the help of a local, well-known climate scientist, Timothy Hall at NASA Gallery Institute in New York. And he produced these nice ensemble tracks. And from there, we figure out what are the 300 storms that we're going to use in our simulation, as I mentioned earlier. Now, Sandy is a 700-year storm, according to Tim Hall in his paper, generated very high surge and wave. The storm ensemble, on the other hand, includes many less intense but more frequent storms, which come in very different sizes and from different directions. Each storm generates very different response in the marsh and village in terms of surge and wave. Some storm with southerly wind flood is buffered by the marsh more, and other storms like Sandy, wave is buffered by the marsh. And some storms, none of them is buffered. So we have to consider the cumulative effect of these various storms to create something called 1% annual chance, or 1% annual exceedance level flood and wave event in the village. And from there, we estimate the damage. Now, I mentioned that the original plan, restoration, management restoration plan, Heather already explained in detail. I'm not going to go into in detail. So we went ahead and did the simulation anyway with this 40 acres replaced by TIFAR in 3 phases over a 10-year period. We did model simulation just to look at what if these restoration plan were going ahead, if they have any impact on the capacity of the marsh to buffer storms. So before we get into the damage, we show the 1% flood, 1% wave height for current climate. Right now, these are in feet. And then these are in 2050 with 18-inch sea level rise. And we definitely see an increase in the flood height, flood elevation, and the wave height because of the sea level rise. So the 1% elevation, wave height increase over time. And sea level rise at Battery is shown here. This is the 90 percentile. This is the 10 percentile. At Battery, we picked sea level rise scenarios based on recommendation of end user, namely Klaus, who is a member of the NPCC, and also team consent. So we picked the sea level rise scenarios based on consent, group consent. So now here is refreshing what we just talked about. Sandy with the current marsh configuration with no vegetation and losses in $1 million, losses in percent of 2018 market value of $580 million. This was something that based on Klaus' comments in our last presentation. So these percent loss went down because this number went up. Previously, we used the number, we used the value of the total structural value of 2018 instead of the total market value, which includes the land value. So the loss percent went down significantly. So what is this 7.6%? This is the avoided loss, which is divided by this way. The loss without marsh, subtracted loss with marsh, divided by the loss with marsh, 901 or 2, I lost the 1,000. I mean, 7.6% is the value.
Sorry,
the value.
Peter, you are breaking up a little bit, Peter.
Okay.
Is that
okay.
Nathan, were you having trouble hearing too? Just want to confirm that someone else is here. Yeah. All right.
So summary of the 1% is flood and wave in for the current situation, vegetation, avoid $2.1 million, 7.3% loss due to the presence of the marsh. So the marsh value, at least the price looks like it's, and also the dollar value is high. More flood and.
Sorry, Peter, you know what? You're going to need to hang on. You're having some connectivity issues. We've just lost the visual for you, and the voice is very broken up.
I turned off the video to ease the bandwidth.
You did? Okay. Yep. Okay, great. All right, go ahead, Peter.
Okay, let me Okay.
Much better. That's much better. We can hear you well now. Keep going.
Okay. Good. So, so my video disappeared. Okay, that's okay. So 1% chance event showing the marsh value is actually increased. And here we run a number of scenarios considering sea level rise and potential marsh management. As I mentioned, we have sea level rise increasing from 2020 to 2050 from 0 to 18 inches. Marsh management scenario, 3 phases, 1, 2, 3 in purple. And they're explained clearly here. Current condition, current vegetation in area 1, 2, and 3, and the rest of the marsh. Area 1 has no vegetation. In 2 years later, there's no vegetation in area 2. All right, and 2025, there's no vegetation in area 3. By the time of 2050, all 3 areas have fully grown high typha, except the rest of the marsh. And so these are the damage values in $1 million, 18.8 to 28.1. These are not a dramatic increase in damage. And if you go to percent, the really change is not that much. What it says is that before 2025, storms dominate in causing damage. And 2050, sea level rise and storms contribute about equally to the damage values and also the percent. So these are scenarios 1, 2, 3, 4. And we have more scenarios from 2050 to 2100. And from 2050 to 2100, we didn't do many more in between because there's more uncertainty in the future climate change effect in terms of the sea level rise value as well as the future storm condition. What we notice is that by 2100, extreme sea level rise, the marsh is predicted to be lost. This, according to NAVA's study, the marsh is lost, and therefore the damage goes up to $63.3 million. But in terms of percent, it's only 10.9% of the total market value in 2018. So I already mentioned that the buffering capacity of the typha of the management scenario would not have impacted the buffering capacity of the marsh. At 2100, the buffering capacity is significantly less because the overwhelmed marsh by sea level rise. The number of properties damaged increases with time. Summary: Piermont Marsh was effective in buffering wave current debris during Sandy, but not in buffering surge. Originally proposed plan to replace fragmite with typha would not have diminished the buffering capacity of Piermont Marsh for wave surge and debris. 41 properties received $3.47 million from FEMA, compared to $3.72 million estimated by our study. When we consider all structures, estimated loss would have been $11.9 million, with the marsh avoided $902,000. Structural loss in the future 1% event will increase due to storms, sea level rise, and marsh loss in 21st century, but marsh will continue to provide significant buffering capacity except by 2100 when marsh is overwhelmed by sea level rise. The Piermont Marsh project tool has developed. This is something that we didn't really put in the proposal, but nevertheless it's produced to allow end user access for resilience planning. And also I think this study confirms that the storm buffering capacity of Piermont Marsh, and it's something that marsh managers should consider. To continue to preserve the buffering capacity, had already mentioned the sediment importance to ensure sediment supply and prevent marsh edge erosion. So in the end, I want to acknowledge the support of the NERRS Science Collaborative with NOAA funding managed by University of Michigan. Lynn Vaccaro is the project manager. I want to thank Lynn for giving us a requested extension of the project so we could complete everything we set out to do and plus produce an added bonus of a web-based decision support tool, which is listed here. Fortunately, I can't show it to you because the website is under maintenance. If you have any question interested in the web tool, you have my email. Write me an email, contact me. I'll be happy to answer any question you have. And it will be available by the end of September. And I just want to give you a bird's eye view, a glimpse of what is coming out from this tool. We have flood maps with property loss in the 1% event, 2020, 2050, 2100. We have different scale. Now these are annualized loss in percent. Annualized loss in percent, this is 0.5% means you multiply by 100 is 50%. That means in a 100-year event, in a 1% event, you would have 50% loss. When you divide by 100, you get 0.5% loss. But a lot of these things are explained in detail inside the web tool. Unfortunately, I can't go into too much detail, but just shows you the damage both in dollar value and percent will vary, will change with time. And so in the end, I like to end this talk with some final remark. Piermont remains a place with outsized appeal. This is according to New York Times. And some of you might recognize this nice picture of Piermont Village, which I enjoy every time I go up there. And also, Piermont Village would be a place where people are happy and healthy and bouncy. And the non-native gets along with the native. And the village is a flood and COVID free. So with that, I thank you and look for open for questions.
Peter, thank you so much. Appreciate it. We've got two questions for you waiting, and let me just again remind folks, anyone who wants to ask a question, if you just put your cursor at the bottom of your screen, you'll see a bubble that says Q&A, and if you click on that, you can type in a question or put a thumb up next to someone else. Peter, you may want to still share your screen because I suspect you may need to, may be helpful to go back to a slide or two. The first question is, am I to understand that in May, the seasonable changes in Taifa, as well as the lower density of the plants and shorter height of the plants, that it would provide less protection during a superstorm? So it's that seasonality question.
Yes. Well, Taifa is, we did two measurements, one's in September, one's in May, and it was in 2017. And there are very little difference between Phragmites in terms of height and density. But Taifa was noticeably different. It was much shorter in May and much sparser in May. So when we put those conditions in the models, it shows that it wouldn't be able to dissipate as much wave or current because it would be inundated by the flow, by the wave and the surge, and therefore debris could get into the village if it happened in May. Now, of course, it's unlikely a superstorm like Sandy will hit in May, but you never know, right?
Okay, thanks, Peter. The next question is, in the short term, it appears that marsh erosion is a greater risk than the transition of Phragmites to Taifa. Is that correct? And I don't know if that's going to be something for you to weigh in on or Heather to weigh in on, but open it up to either one of you.
Well, it is something that we were not tasked with. We were not, remember we got funded by, it's interesting, the reviewers said they liked this proposal very much, and the NERRS Science Collaborative review team, they liked it so much because it's very focused study, focusing on this storm buffering capacity of marsh. It's not a catch-all study.
Right.
Now, these are sediment erosion things are related issue we could have investigated, but it's not something we were really prepared to investigate. The sediment you need to do smaller scale experiments with sediment sampling, which we could do, but we were not tasked to do that. And we could do those modeling, and then Heather talking about, the wave energy, how it dissipates, how it interacts with the mud, cause erosion, but we didn't do much of that stuff because.
Yeah, and I can add to that. I think that erosion that we think we are seeing is over 100 years. So our hope with the transects is that we'll be able to pick up on an increased rate of erosion. We're hoping that we can couple that with the pilot project to really focus in where we're seeing potential increased rate of erosion and really well-placed pilot project. I guess I'm worried about the erosion, but if we look at a long term, it probably is eroding at a rate that's not unreasonable for a natural system.
Thanks, Heather.
Add on to that a little bit, I think one of our concerns is that the Phragmites could exacerbate the erosion too. A lot of times where there's native plants at the edge, particularly Spartina, you have more of a gradual elevation gradient, so there's not as much erosion, but when you have a steep edge of Phragmites, the waves sort of scour under it and cause it to slough off and create more erosion in some areas. So that's part of the study that we're investigating.
Good. Thanks, Sarah. I've got another question, and again, remind folks, just click on the Q&A, and if you've got another question. This question is, if storms come more frequently, could that reduce the effectiveness of the marsh buffering, either due to erosion or damage to the marsh plants?
Yes. So we have similar situation in Florida. We don't worry about Phragmites, but we have a lot of mangroves in Southwest Florida, and Hurricane Irma damaged a lot of mangroves. It damaged the canopy, therefore damaged the buffering capacity of those mangroves for flooding. Fortunately, we didn't have two of those storms in the same year. But in Puerto Rico, that one year, there were two major storms, Category 4 storms hit Puerto Rico. One is Maria, one is Irma, and they caused devastating damage to the mangroves. So therefore, the buffering capacity was significantly lost. That's why I have one student studying the impact of hurricanes on the mangroves, and therefore its buffering capacity. So ideally, if you get two Sandy hit this area, I'm sure you're not going to see the same buffering capacity. Some branches going to be lost during one storm, and the next one comes. You're not going to have the same density. Therefore, you're going to lose some capacity.
Thanks, Peter.
Sure.
I'm not seeing any other questions right now in the Q&A. So again, we've got another couple of minutes. If there's any other questions that someone want to throw in there, here's one. You measured the Taifa in May, not in April or June. It seems that for a portion of the year, as yet to be determined, Taifa is less effective in limiting storm surge and wave damage. Why would we pursue a change to Taifa? I'm going to suggest that that's probably a policy question that maybe, Peter, isn't part of your study. So I don't know if I'll open that up to anyone on the panel who would like to respond to that.
Well, one of the reasons this is Heather Gerloff, we were pursuing potentially controlling Phragmites to enhance the native vegetation that's there at Piermont Marsh. Because when we have a marsh that's rich in species, then if anything does come through this marsh, we have the better ability to buffer it because we have a variety of different plant species that might be persistent after a storm event or flooding or whatever it might be. Taifa is a good one to use for modeling. And so I think that's why we refer to TIFA. It's something that you can see at Iona in the transition from Phragmites to native. So the reason why we're pursuing it is to try and enhance the native vegetation in the Piermont Marsh.
Thanks, Heather. All right, let me just see. I think we don't have any other questions at this point. So Peter, thank you very much. Appreciate it. And if you will stop sharing your screen, Maggie will grab it back and call up Nathan.
There you go.
Nathan Mitchell. So thank you. Thanks, Peter. So at this point, I want to ask Nathan Mitchell, who's, as you know, Piermont Village trustee, to talk about what are the village's plans for going forward and think about some next steps. So Nathan, over to you. Or actually, before you do it, let me just ask, there's one last question that popped in the queue here. It says, does Phragmites, it actually says, doesn't Phragmites enhance sedimentation? So what's the relationship between Phragmites and sedimentation?
I'll take a stab at that one. Phragmites is growing at a higher elevation, so it's quite possible that the sediment isn't getting in as far. And I've actually got a study going on in Piermont Marsh where I've installed sediment elevation tables from the shoreline all the way out to the river's edge to get a better idea if the sediment is able to move into the Phragmites. So we're working on investigating that further.
Thanks, Sarah. And a question, one last question just came in. It says, do these findings change marsh management's point of view on Phragmites value?
Well, I can answer that a bit in that I think with the marsh, what the research showed is that whether we had TIFA or Phragmites, they both provided significant buffering capacity. I think it's key that the attendees know that at this point, we're not looking to pursue the control of Phragmites in any large scale. We are just looking at controlling it in very small locations to try and just hold on to a little bit of the native vegetation that's there in the middle of the marsh and persisting.
Thanks, Heather. Okay, with that, Nathan, this time really over to you.
All right, well, I just wanted to start with thanking everybody for coming tonight, and also thanking everybody who's been involved in making this project happen, from NERRS to NOAA to New York DEC, everybody on the project team, the research team, the planning team, and also the end user group. This was a very large endeavor. There were a lot of people put in a lot of time to come to these outcomes, and so essentially, just in a nutshell, there was a lot of very technical information there, and I'm not expecting that everybody absorbed 100% of it, but from Piermont's perspective, what we learned from this is that the marsh significantly reduced sandy wave damages in adjacent properties, and that the marsh will provide a valuable buffer in future storm events, perhaps even more so than it did during Sandy, but that we may lose that buffer protection due to sea level rise or other health of the marsh issues. And so those are things that should be concerning to us, and we should be working to try to protect the buffer that we do have. Slide. So how this helps us plan for the future, the buffer project itself, the sea level rise and the model scenarios gives us very good information about what kind of future impacts we should be expecting. And the web tool that was produced as a result provides the best data that we have seen so far in estimating future storm damage in terms of economic impact. And it also provides guidance not just for the village, but also for individual property owners or people who are looking to do some construction in an area that might be affected by flooding. And then there's some other information that came out of the project that was related. The LiDAR mapping benchmarks will give us a great way to be able to track if shoreline erosion is impacting the buffering services that the marsh can provide in the future. And it also demonstrates that living shoreline projects in other vulnerable areas in Piermont could provide additional buffering services beyond what exists now. So there is a project that the village has been pursuing to look at doing a living shoreline project off of Pirelli Park on the north side, which is an area that is impacted by very typical nor'easter storms more severely than the marsh area is. Slide. So using the web tool, which is going to be available at the beginning of October, is something that we're going to encourage residents and policymakers alike to get involved in and do. It's a bit technical. It requires a bit of training, and we are at PWRC putting together a packet to include this tool as well as some other tools that are currently available in a training routine, so that we can, show everyone how to use it and get the most out of it. But the model can be viewed with various levels of sea level rise. That in the Sheng study we had associated with specific periods in time. But it doesn't necessarily mean in 2050 it's 18 inches. You could look at 18 inches and say that's going to happen earlier than 2050 or later than 2050. The tool lets you pick the specific amount of sea level rise that you're dealing with. So that gives you some options in how to look at things. Slide. So for example, this is a screenshot from the web tool where we're showing 18 inches of sea level rise, and you can show just the flood depth itself, just the wave height itself, or you can show both of them together. And the color code will just, give you the reference for what amount of elevation of water would be found at that spot. Slide. And now this is the economic impact analysis portion of the tool, which is really a great thing that we've never had any good way of looking at before. And so this is a terrific resource for us. But again, this is a screenshot indicating 18 inches of sea level rise, which for the purposes of the study was what we were using for the 2050 timeframe. But again, could happen before or after that. But this does translate wave height and flood height into something that for a lot of people probably makes more sense, which is what is the annualized economic damage at that location. Slide. So as I said before, it's complicated enough that we're going to need to do a short lesson for everybody that would like to use it. But if you contact me at nmitchell@piermont-newyork.gov, we will schedule a call and train you how to use the tool. And we're here to support our residents learning how to utilize all of these resources as they come in. And so you can, Pete had earlier mentioned that you could send him an email if you have questions about the web tool, and you can also email us at PWRC if you have questions about the web tool or anything else in the presentation. And the details of all of this are not immediately available, but in the beginning of October, we'll be sharing the report as well as the tool with everybody who's interested.
Thanks, Nathan. We're going to shift to wrapping up here shortly. I do want to see if there's any last questions for any of the presenters, for Sarah, for Heather, for Peter, for Nathan. We can take a couple more. There is one question. It says, what are some of the native plants we want to encourage? So let whoever would like weigh in on that one.
Well, right now, the area that the Phragmites is being controlled with the geotextile is surrounded by native vegetation. So that native vegetation is a chairmaker's bulrush. We also have Spartina on the edge, which we're hoping to protect. So really, and cattail is something, marshmallow, if anybody has gotten themselves into a native area of Piermont, it's eye-opening. You kind of guess your way into this Phragmites and you spare some blood, and then you're rewarded with marshmallow flowering and dragonflies and and birds. So it's all those things combined that make a really nice biodiverse marsh habitat. When I was there, we found a bedded down deer area. Like I said, it's just amazing. So those are the combinations that we hope to enhance in the middle of the marsh and hope to expand in the long term.
Great, thanks, Heather. And Peter, I want to invite you to turn your camera back on, or Maggie, if you can do that for Peter, just so we can see you. There's another question here. It says, have the use of pesticides in the Piermont Marsh definitely been ruled out?
Well, I imagine that's for me. Definitely, I mean, at this point, we're putting a pause on that. Would that mean for the long term? I don't think it would be a responsible manager to say that from now and forever, we're not going to use chemicals. It potentially is going to be a tool in the toolbox. I think I can commit to saying that 40 acres is not in our future. potentially not even 10 acres at a space. But you know, if we are wanting to save this native vegetation, we are going to have to employ a number of tools in our toolbox to protect them. And it will be key to maintain biodiversity and to maintain habitat at Piermont. You know, if we let Phragmites dominate the entire marsh, we'll be unfortunately missing a key habitat in an area that's in a key location in the Hudson. You know, we have salinity there. If you go onto the marsh, you can see the dried up salt, which is unique. We don't have a lot of that in the marsh area, Yonkers, Hastings. There's no intertidal marsh in that space. So Piermont fills a really important niche that we want to try and protect.
Thanks, Heather. Question is, did the 50 feet of marsh edge loss extend over most of the edge or just in certain areas?
It's not consistent. That's why you see the scalloping. I would say that if I were to say the 50 feet is probably in the areas that are scalloped and probably the extreme.
Thanks.
But that's the reason why we really do need to have our benchmarks and our transects, because honestly, when you look at ortho imagery over the last 100 years, it's really hard to overlay them and say for sure 50 feet. Because you know, we just don't have the resolution from 1920 compared to 2020. So the transects will help have a better sense on the next, say, 5 to 10 years. And we are committed to that. I mean, one of the things that we want to commit to in that management plan, both in 2017 and 21, is to increase our scientific knowledge of these current conditions in the marsh.
Thanks. And Heather, apparently your description of the marsh was so captivating, truly, that it inspired the following question. I know this is off scope for this group, but is there any talk about making walkway access into the marsh so that people can actually see the kinds of things you were just describing?
Yeah, I mean, wouldn't that be great? It's really difficult to construct anything like that inside the marsh. But we have geotextile going in. And so we have a track of people that are going in and out, which means that we'll have better access just by de facto. If we let that go in a year, you'll have to really hammer through that marsh again. But I think that it's valuable if people are interested. If there's some way that I can facilitate some visitation of the native marsh, I certainly could entertain that. At this point, like I said, we have a walkway path because we had to get the geotextile in, and the geotextile is quite large, and we went in from the interior of the marsh. So if there's some benefit to me bringing some people out there, really getting to see and be immersed in this beautiful location, I certainly would try and do that.
Thanks, Heather. And Nathan, I'm going to assume you just made a note on that to yourself, but I think that might be something to potentially follow up on. And the person who asked it says, Heather, you lead the tour. We're game.
Bring your long sleeve shirts, because man, going without a long sleeve shirt, you're donating a lot of blood to that marsh, and it's the Phragmites.
Good. All right. There are no other questions, and there is almost no other time, so that works out quite well. Actually, 2 questions just came in. One says the advertisements by law firms for a class action suit against the makers of Roundup, which is glyphosate, because it causes non-Hodgkin's lymphoma, is scaring me. Is there a relationship to what you want to use?
Well, we originally put planning on that, but I think what you're seeing in the lawsuits is quite different than the application we predict we would have used in Phragmites treatment. In the Phragmites treatment, we'd be using it with the proper PPE, the correct ratio. And the way it works in the glyphosate in the Phragmites treatment area is we apply it to the leaf. The leaf brings in the chemical down to the root and it kills the roots. Once it's getting to the soil, it gets bound up and it's not really releasable. And so I think sometimes we hear about what we hear about in media and in these lawsuits, and it's hard because it doesn't give you a lot of detail. When we went through it, we found that it's really the only and the safest way to do it in the quantity we were looking to do. Will that mean that in the future it'll change? I imagine that there'll be other chemicals in our future. I don't know what we'll do with that. I'm confident with the way that we applied it. I have an aquatic pesticide permit license at one point. I sprayed chemicals and I just did it the way that you're supposed to do it in the right mixture. and the right application rates. And I didn't fear for my health, and I feel like this application would have been safe for anybody out there.
But again, just to be clear, that is an issue that is on hold.
Correct.
At this point.
But we heard,
just,
you know, to make it very clear, the state heard the concerns from the neighbors and the constituents that this was something they were concerned with. So we are putting that on hold. Great.
Thanks. And I will just note that there's a comment in here that while access to the marsh offers an opportunity, that there's a question about might that affect the wildlife. I don't think we need to answer that right now. I just want to put that there as a question, something to be considering.
Well, maybe we can close out and have a GoPro on it or something. We'll put a camera on our heads and we'll be able to record it so we can share it more widely.
Yeah. Great. Okay. I do want to wrap up though, because we are coming up on 8:30. If you haven't seen it already, if you look in the chat, you will see a link to a survey. We'd love to get some feedback about what you learned tonight on the session. So if you click on that, you can fill that out. We also will send it out by email, so you'll have that link, and we would love to get the feedback. You have until next Thursday to do it, but I would predict that if you don't do it by 9:15 this evening, the odds of it getting done are probably pretty light. So we really would welcome the feedback. So if you take a moment and click on that link or copy it, then you can fill that out. I just want to say then, by way of closing, just thank you to all the presenters for the information you shared tonight. Particularly, obviously, Peter, thank you to your team, to you and your team for all the work you've done over the last 3 years. To the planning team, to the end users, we've referred to the end users a bunch. You know, that's folks like Nathan and Klaus and Sylvia and Usha and others in the village and McGowan with the reserve, who have given a lot of time to guide this, give us advice, give Peter a lot of advice on study approaches that would really make it relevant and valuable to Piermont. So I just want to put in a really big thanks to everybody who's been part of this effort. And then just finally, a reminder that, again, the presentation has been recorded tonight, and that will be made available. The presentation itself will be made available, and as well, there will be a project summary written, and that will be made available as well. All of that will be available at the end of September. And again, we'll keep the emails of folks who registered, because that's obviously a group that's interested, and we will remind you at that time when and how to get access to any of that. So with that, I just want to thank everyone very much. Thank my colleague Maggie for helping out on the technology, and just wish everyone a very good evening. So thank you all very much for making the time to join with us tonight.